And live.
She says we're live.
Let's wait a couple minutes for people to hop on.
Hop on. Let me giddy up. Let's go.
All right, let's just jump right into it. So, welcome back to Buckle Up. Today's topic is summer service calls, what to look out for, what to do. Brian is an expert, so ask away all your questions for this summer.
I'm an expert at drinking Diet Pepsi.
Our next Buckle Up is July 8th for mini splits, and we're going to actually have a special guest sitting right there.
July 8th.
July 8th.
It's right there.
Let's do a quick little
can they hear us?
mic check.
Mic check. Nope. No mic.
Not today.
Just this guy.
Woo-hoo. All right, Brian, you ready to start with some questions that were sent in to us today?
Well, yeah, we can hit the questions, but I always like to do this whole
Go
piece
for it.
where, kind of give you a background of why I or we, sorry, Mike, we pick these subjects. So obviously we've finally gotten into summer. Mother Nature's temperatures going up and down. We're getting rain, thunder, lightning, very, very frightening kind of stuff. But at any rate, the common problems, high head pressure. You can rinse the coil with water, the condenser coil with water, and you can reduce the head pressure, yes. But, these micro channel coils, very, very sensitive to chemical cleaners. Something that I used to do, and I've told a couple of guys already this season, is, hey, just, get yourself a spray bottle and mix up your own soap and water solution. I mean, if it's good enough for your dishes, it's good enough for the condenser. I'm not going to eat off the condenser, but, the dishes, grease, oil, food stains, whatever. But if it's good enough to clean dishes, it's mild enough to clean the condenser coils without eating up the aluminum and the copper. I know that there's machines out there that have to be chemically cleaned, and they make them specific for taking off certain minerals and stuff like that. But if you can get away with it, get away with it. So we wanted to hear from you guys on the general, what are you running into out there? Try and help. It's going to be a long summer. So toss your questions out. We're here, or at least I am, because no mic. Mic check.
All right, we got one.
Okay.
Ready?
I'm ready.
All right. Should micro channel coils be repaired in case of a leak?
Yeah, see, I'm old school, and micro channel coils are aluminum, and I never trusted myself brazing up aluminum. There are kits out there that guys say that they can fix the micro channels. I've never been able to fix a leak in a micro channel aluminum coil. Sorry, no. So, my opinion, can they be fixed? Nope, they can't. But there's guys that'll argue with me all day long that say they can do it. I tip my hat to you. If you can get an aluminum coil hot enough to melt aluminum and not create more holes or plug up those little orifices that are inside that micro channel, you're a better brazier than I am, and I'm not afraid to admit it. So.
All right, we'll go to one that was sent in today. What should my superheat and subcool be?
Well, superheat and subcool, the manufacturers set that. But if you're in a jam and you're trying to get off of a job, I've always used 10 and 10. So typically, depending upon which manufacturer, some of them want 9, some of them want 12, some of them want somewhere in between. So, I tell everybody 9 to 12, if you're in a jam and don't have it, and I'm not in front of my computer, can look it up, try and shoot for 10. If you're, and that would be for both, 10 to 12 superheat and 10 on subcool if you have a machine that's designed refrigerant. Going back to the blends, the new blends that are out, charging the old R22 machines, that's a totally different, that's a whole different class. So.
Cool. All right, what are my possible issues? My unit is shutting off on high head pressure and my suction pressure is below 90.
Okay. Higher than normal, or normal head pressure, or normal to high head pressure, and your suction pressure is low. The pressures that he's talking about in that question is 410A machine. So it's got normal to high head pressure with not the normal suction pressure. Suction pressure is lower than normal, which means that his superheat is probably elevated, and his subcool is probably elevated as well. And that is a sign of a restriction in the metering device. And we've seen a lot of those again this year. We don't take tech support calls on machines that are working. So you guys don't take service calls on machines that run fine. So what do you see a lot of? We're seeing a lot of the 3 to 5 year old 410 machines that are plugged up in the metering device, expansion valve or fixed orifice. On the fixed orifice stuff, you can usually pump the machine down or recover what you can, or what you can't pump into the condenser, and you can take it apart and clean the orifice, get some kind of a degreaser, because it's getting plugged up with, I know in the mineral oil machines, it was a paraffin that built up, kind of a wax. It could be the same exact thing, a wax buildup on the POE oils, but at any rate, that's probably his problem. He probably has a metering device issue that's plugged up. So the other way of confirming that, your superheat will be high, but your delta T on the evaporator. And for those guys that don't remember, delta T is the difference between the entering air of the machine and the leaving air of the machine. So it's delta T, delta temperature.
We have a question that's related to that from Landwater90, and he's asking, why are my pressures going up and down on 410A, low charge or overcharged?
Or non-condensables. What's your suction pressure doing? If your suction pressure is stable, your superheat is high, and your pressures are bouncing. And when I say bouncing, I, as a matter of fact, had one today. The guy was bouncing like 200 pounds. Superheat was 25 degrees. And even though I'm not used to seeing that, he had an expansion valve, and I believe the expansion valve was sticking. So it would jam open finally, and his head pressure would drop, but it would close and stick or something. I suspect that he's got something going on with the expansion valve, and it was a TXV, not a fixed orifice. So when we, back in my startup days, nitrogen would, if they didn't do a good evacuation and vacuum, and nitrogen was left in the system, nitrogen would make our head pressure bounce. But usually wouldn't come down below normal. It usually stayed above normal, but it would be a 60 to 100 pound bounce. So that's why I said non-condensables. Depends on what your superheat and suction pressure are doing.
Could you subcool in VRF? How to check the charge? Thanks again.
On the VRFs, it's you can check them if you know what it's supposed to be, but every VRF or VRV manufacturer out there, they've got their service tool, and you hook up the service tool and follow their instructions. because multiple heads, you got to be able to look and see what the EEVs are doing on all the heads, and it'll tell you. They've got the sensors built into them already, so as long as you've got the service tool or the maintenance tool, then all your readings will be in there, and it's not like you're taking out your field piece stuff and putting it on there.
Next one. Is it correct for a condensing unit to have a hot gas bypass and a fan cycling switch, or is it one or the other type thing?
No, you can have both. You can have hot gas bypass and fan cycle control. The hot gas bypass maintains or puts a false load, if you will, on the evaporator, and the fan cycle control indicates that you're probably going to be running the machine in cooler weather in the case of a data room or something like that. So you want to maintain the condenser temperature, kind of want to fake it out, make it think it's 75 or 80 degrees outside when in fact it's 45 or 50. They'll put a fan cycle control on to maintain your head pressure. And then if you're in a data room, a lot of data rooms, they want 68, 70 degrees. So in order to get that without icing up the indoor coil, you put a false load on it. So the hot gas bypass puts the false load on the evaporator, and the fan cycle control puts a false load on the condenser. So yeah, it'll have both.
What are
Good
some
question.
common reasons for high suction line temperatures?
Common reasons would be low on refrigerant, out of refrigerant, high return air temp. So a lot of refrigerant related problems. If you've got warm suction line, you're either heat pump and the reversing valve stuck, straight cool unit, you either have a high extremely high heat load in the space, or it's pretty low on gas, pretty low on refrigerant.
All
I
right.
like them. Keep them coming, guys.
I have 24 volts at the outdoor unit, but the condenser fan motor and compressor are not running.
We get this one a lot. Straight cool machine, 2 wires coming from the indoor unit. Doesn't matter what color they are. One of them's going to be hooked up to the Y, and one of them's going to be hooked up to common. If you're reading 24 volts from Y to chassis ground, and you read 24 volts from common to chassis ground, you're wired wrong. And we've had that. The guy accidentally hooked his common back up to R at the air handler, and I think he smacked his apprentice like 3 or 4 times for that. But live and learn. A lot of times you'll be reading 24 volts, but you're not actually getting 24 volts because it's not a complete circuit. The Y wire will be solid and actually giving you the signal from the thermostat, but your common wire can be broken. And if your common wire is broken and shorting out to ground, it's not making it back to the transformer, but you're getting a false read. So always, if you think you got 24 volts and it's not pulling in the contactor, so you read the wires going to the contactor, and if it says 24 volts and it's not pulling in, check your common wire going back. That's one scenario anyway. If that one doesn't work, call me on the phone. We'll go through the other ones.
I have a communication system, and the display says I have an inverter issue, no communication.
We all love the new communication system, the communicating systems. And a lot of times in the communicating stuff, if you just, and I know I've referred to this as noise before, but they do pick up noise. Regardless, if it's saying that you've got an inverter issue, power it down. make sure that you have turned off the power to the indoor unit. Make sure you've turned the power off to the outdoor unit. In that particular case, it doesn't matter which order you do it in. When you start the machine back up, you always want to make sure that you turn the indoor unit back on power-wise first, then turn the outdoor unit on. The outdoor unit will go through and find, because the stat communicates with the furnace, but it also goes out and looks at the condensing unit. If it sees the condensing unit first, it won't recognize it because it's obviously not powered up. So condensing unit is last. And that usually resets that error. And you get that, it's a nuisance error if you have a power outage and one or the other doesn't come on at the same time. And ECM motors too, on power backup from a power failure, they will a lot of times start themselves back up. They'll spin one direction, they'll shut down, and they'll spin another direction, and it's looking for its correct rotation. So how it does that is it looks at the amp draw. If it's running backwards, not moving any air, or the designed air, if it's not moving the designed air, the amperage will be down. When it's going the right direction and moving the correct amount of air, then the amp draw will be up, and that's how the motors know which direction to spin.
My company wants to start recommending to replace reversing valves when replacing compressors. Is there a way to check a reversing valve that has seized or shorted compressor on that pertaining unit?
I agree with your company 100%. I've been using that particular philosophy since, for a long daggone time ago, when I replaced a broken compressor and I didn't replace the reversing valve. And as soon as I fired the machine up, I found out that the reversing valve didn't slide. So we went down and got a reversing valve and changed it. So from then on, anytime you have to replace the compressor, you should replace the reversing valve, because the slide, any bit of dirt or debris that gets in there, because it's such a close tolerance, in the case of a burnout, you're going to have sludge up into the reversing valve. If it was a broken compressor, you're going to have metallic parts up in the reversing valve. So any or all of that is going to affect that reversing valve being able to slide. And if you look at them, most of the reversing valves, when you replace the compressor, that would have been the best time to replace the reversing valve instead of coming back later and trying to do it with the new compressor sitting in there. So that's why they're asking you to do it, because 99% of the time you're going to have to do it again anyway.
Cool. I have the indoor fans running and I have no 24 volts at the outdoor unit. What do I do?
24 volts at the indoor, and the indoor fan is running and nothing outside. If you truly have nothing outside, look at the board, indoor board, and read that. If you don't have 24 volts between Y and C at the indoor board, then look at the thermostat. And Mike and I have talked about this before. You can take the thermostat off the wall, and guys, I had one today, brand new thermostat, wouldn't energize the G. We confirmed it every which way from Sunday. It still wouldn't energize the G through the stat. Took the stat off the wall, ran a jumper from R to G. Fan came on. Put the thermostat back on the wall, called for cooling, condenser started, no indoor fan. Bad thermostat. So, take thermostat off the wall, take a jumper from R to G, take a jumper from R to Y. If the condensing unit starts, if you get your 24 volts where you need it to be, then it's got a bad thermostat. If you have 24 volts outside at the condensing unit and it's not running, look at your pressure switches, circuit boards, things like that.
Question from Kevin. He's asking, 3-phase motor goes out on thermal overload, yet amps are less than when running than when on load.
One more time, Kevin. She's going to read that to me one more time. Three-phase motor.
Three-phase motor goes out on
thermal
overload, yet amps are less than when running than when on load.
Yeah, Instagram is messing with your question, Kevin. The amps show less than full load, and it's going off on thermal. You have to check your voltage and make sure that your voltages are correct, that you're not almost single phasing it. Double check your 3 legs of the contactor that's pulling in that fan, and make sure that you don't have more than 1 volt difference between L1 and T1, L2, T2, L3, T3. Read across those. If you have L1 and L3, if they're reading 0.5 volts and L2 is reading 0.9, get rid of the contactor. And if it has anything over a volt, get rid of the contactor, change it out. So you may be actually dealing with a voltage issue, and it's messing with the motor's almost thinking it's single phasing, and that'll overheat a motor big time. So they don't like to be single phased. Single phase is when you have a 3-phase motor and you lose one of the legs. Then you only have 2 hots, 1 dead, and that usually ends up smoking the motor. So look at your voltage, buddy.
What do you recommend when it comes to thermostats?
See, personal preferences, man, that's tough. The simpler the better. The best thermostat you can pick up is the one that you understand how to work with. If your company that you're working for has a standard, then you'll know the ins and outs, and that will be your favorite thermostat. I have an Ecobee in my house. A lot of my friends have the Nest. It's all personal preference, and everybody's pretty much doing the same nowadays. The Honeywells always put out a decent thermostat. Brayburn has put out a decent thermostat. So, but again, it's your personal preference, and everyone's going to program just a little bit different, even though they all program a lot the same. So, run with that. Sorry, I couldn't be more specific. It's like which communicating system do you like the best? I don't like any of them. But this isn't old looking for no reason.
What would the normal time delay when you turn the thermostat on before the outdoor unit starts? I have a unit that takes 10 minutes to start. Is that normal?
10 minutes is not normal. 10 minutes, it kind of goes back into the thermostat question too. Most of your digital thermostats, if not all of your digital thermostats, they're going to have a built-in 5-minute time delay unless you program it out. If you have in your case that your 10-minute delay before the compressor starts, chances are your condensing unit also has a 5-minute delay in it. So you have the 5-minute delay in the thermostat, then you have a 5-minute delay in the condensing unit, and you add those two together and you've got 10 minutes. So if you can't disable the 5-minute delay in the condensing unit, which is probably the case, then you can go into reprogram the indoor thermostat and take the delay out, because the compressor is being protected by the unit outside. So, good question. Come on, guys. I need more Pepsi. Let's do this.
We'll do another one that was sent in through email today. My blower motor runs after the thermostat shuts off. Customer says about 15 minutes. What would cause this?
Blower motor continues to run after the thermostat shuts off, that can be normal. For the customer to say it runs for 15 minutes, customers are never wrong, so time it. If it should be 1 to 2 minutes, and it's the energy In California, they call it Title 24. Anytime the condenser or compressor shuts off, they let the fan run for 1 to 2 minutes to continue to move the cold air, and they call that energy efficiency. So if it truly is sticking and holding out for 15 minutes, then I wouldn't trust the timer and I would replace the board.
Cool. What's the best way to clean a unit? I know you talked about this a little bit before. And what type of solution do you recommend?
Non-corrosive. As non-corrosive as you can get, and if you're cleaning an indoor evap coil, do not use anything that smells harsh chemical. That you'll drive them out. Find something that's got a, well, on all the indoor coils I ever used was, or ever cleaned, I used Simple Green. That was my go-to on all the indoor coils, because Simple Green's got a nice smell. It doesn't smell like Clorox. It doesn't smell like Lysol.
It's okay
It
for the
smells
environment.
and it's okay for the environment. And so, minty fresh. We just brush the machine's teeth. So between Simple Green and a soap and water solution, and like I say, if I had to get into something, then I would go get as friendly a chemical as I could get, depending upon what I was working on. If it was, because I worked on a lot of equipment next to the ocean, and the coils get pretty brittle. So I would try and be as gentle with them as possible and stay away from the acidic stuff. So I used a lot of soap and water and Simple Green.
Cool. Next one. Do we need a special tool to communicate VRF/VRV multi-head units?
Yes. I think we touched on that with that other gentleman earlier, that when you're servicing these VRV, VRF systems, you've got a service checker that, I believe you got to go to the class, you've got to be trained, and then you can get the service checker, and it'll tell you everything wrong with that machine. The error codes, you can look up error codes all day long on the multi-heads. If there's an error, it's going to show up on the display, and you can look them up. And for the guy that doesn't have the service tool, my only recommendation would be to power down the system, power it back up. If the errors go away, you're a winner. If they don't, call the guy with service checker, because it's obviously deeper than that. I have not seen a VRF, VRV, mini split, anything that told you that you could top off the charge. It was, everything I've ever read is, if you've got superheat, subcool issues, you're pulling the charge and weighing it back in, because it was all designed at the beginning. So service tools a must. I know on my when I was doing the city multi stuff, I had the service tool and tied into the computer and sit out in the parking lot or on the roof and go through all the EEVs, all the air handlers, all the BCCs, all that stuff. So it's a time saver, actually. You sit there with the computer and look and see how everything's operating. And yeah, sorry, rambling, but yeah, good service tool.
All right, guys, cool. We'll start to wrap it up here if you have any last questions. And we're back. Cool. Sorry, guys. Wi-Fi just cut out for a second.
Hate it when the Wi-Fi just takes a bail. You guys are familiar with that. You got phones. You know when the Wi-Fi takes a dump. Uh-oh. Oh, yeah, I'm good. I didn't boil over.
I had a 250-pound recovery tank blow up a hose during a recovery of a chiller. The tank slid like a torpedo and almost hit me. It damaged the condensing drain line and hit a gas line for a gas package unit. What would you have done to prevent this?
First of all, thank God you're all right.
Yeah, that's bad.
You no doubt had the 250-pound bottle on a scale, but you still need man, watch your freaking pressures, man. Having a bottle flip over, that's just a damn scary thought. I've seen videos, but yeah, you just gotta be really careful. And I understand once it's on the scale, you just gotta be super careful that the shit doesn't tip over on you. But the bottle should be, if you can't strap them to something,
He said it was laying sideways, 100-pound circuit.
Was laying down on its side. I don't know how I mean, I get it, the hose burst, but was laying down on its side. If it was laying down on its side, you should have been able to secure that bottle.
He said had it sideways, watering it with a hose to cool it down.
And the hose popped, huh? Did you overfill it? Did you not have it on a scale? Your burst pressure on the hoses was 600 pounds, or should have been. Regardless of what refrigerant you're doing, you should have a 600 to 1,000-pound burst rate on your hose. And I'm glad you're all right, man. That's the main thing. Then you were cooling the tank down, but another trick is if you're running something that is that warm that you gotta water the tank, get some type of a quench that you can. I mean, I made 3/8 half inch. They make them commercially now for the. I can't think of the name of it. Some kind of formulator. Mike. I can't think of, but I made my own. I had a 3/8, I had half inch, I had 7/8, depending upon what machine I was using, and I could just sit there and run water in it or pack it with ice as it left the recovery machine, and to try and keep the tank temperatures down. Temperature's pressure, guys. So try that as well, and then secure them damn tanks, man. Weigh them.
Okay, we'll start to wrap up here. Reminder, our next Buckle Up is July 8th.
Be careful on the 4th of July. I want you guys to keep all these digits. You know, we talk about that stuff all the time. So July 8th, we'll be back.
Special guest is going to join us.
Yeah.
We're going to be talking about mini splits. It's going to be a really cool one. So
Mini splits.
mark it on your calendar. Tell your friends. It's going to be awesome.
Download the app. Totally free. Tech support. Totally free. The new forum, man, we are this close
Next
to having
month,
our freaking
July.
platform up and running. This close. You can taste it.
It's going to be so cool.
It's going to be awesome. You guys
You'll be able to search by
are,
line, OEM,
yeah.
see discussions on other units.
Talk amongst yourselves, kind of like we're talking amongst ourselves right here, only you're going to be doing it in the forum. So
It's huge.
guys in Cali can be talking to guys in New York, having the same problem, different machine, same machine, similar problems. We're super pumped over
Make
here.
sure you have your app updates automated so you won't miss that huge update.
It's coming.
So go into your settings, make sure it's automated so you don't have to worry about missing out.
Set up your profiles in the app too. Upper right hand corner, click your profile, fill out your info.
Get your hat,
Get your
all
hat.
the good stuff.
That's right. We don't sell it. It just gives us your address to send you a hat.
Yes.
We don't sell nothing.
All right.
Well, we sell refrigerant, but
That's true. TDX20.
but not your info. We don't even know what the hell your password is. Honest.
All right, guys. Thanks for tuning in, and we'll see you in 2 weeks.
Peace, guys.
Peace.
Thank you.